Electronic oscillation describes the way a power supply moves along a circuit or cable. In a simple direct current power source, the energy will move from point A to point B in a direct flow, whereas in alternating current power, the current or voltage will vary polarities throughout the flow of electrons in a sinusoidal waveform. Electronic oscillation is the constant disparity of the voltage or current in a circuit leading to a periodic form being created. These are primarily square waves or sine waves. Oscillation is a type of periodic motion, a motion that repeats itself at a set rhythm. If a flow of current or voltage is oscillating regularly, the rate of its motion can be quantified as its frequency, and it is measured in Hertz, being the number of times per second that the cycle repeats itself. The time it takes one particle to return to its starting position flowing in the same direction is known as its period. Frequency is figured out using the equation 1 on its period.
There are various different waveforms, each with characteristic features and equations. 4 waveforms are sinusoid, square, triangle, and sawtooth, each with a distinctive look that matches their name. Sinusoid wave equations can be expressed in the form shown on the bottom left. Using the waveform, an equation can be derived, with A being the amplitude or displacement from equilibrium, either sine or cosine depending on the start point, capital T being the time required to complete one cycle, and lowercase t the time at the point of interest. By picturing the cycle as a circle, value 2 pi on t can be used to replace omega for angular momentum. Square waves can be expressed through different equations, such as the sine function of a sinusoid, or generated using the floor function. Fourier expansion can be used with cyclic frequency f over time t to generate an ideal square wave with amplitude of 1, which is represented by an infinite sum of sinusoidal waves. This provides us with easy calculation of where the wave is up to in its cycle.
The concept of oscillating motion can be observed and applied to different forms, such as mechanical, biological, and electrical. For example, the LED lights sometimes flicker on a video camera. This is because the light strobe at the same frequency of the electrical power. If the frame rate of the video capture is close to the frequency, then the effect becomes very noticeable. As we can see, the wave formed by the electrical and magnetic fields is a sine wave. Electrical engineers took advantage of the oscillating nature of sine waves to make LED lights more efficient. We can calculate the frequency of a light bulb with this simple mathematical equation.